Okay, in our last lesson, what we saw was that we were exploring the idea of there being a relationship between two quantitative pieces of data, two quantitative variables. And so what we did was we created a scatter plot. And so we said, hey, look, let's imagine this, see if there's some kind of association between these two. So the first thing we did was say, hey, is there an explainer? Does one of these variables explain the other? And so sometimes yes, sometimes no. In this new lesson, it's going to be super important that you establish that. So in this story, we said, okay, let's suppose we think that the third exam score is helping us to know something about how someone will do on the final exam. So we graphed this like a set of ordered pairs where the third exam score is the X and the final exam is the Y. You get all these dots created from all the various data points. These are all people who took both tests. Now, let's do better than just imagine to see. So from here we said, hey, if you were to describe the scatter plot, tell me the form, the direction, and the strength. And we would calculate R from our calculator, and we would be able to learn quite a bit about whether it was a strong line, whether it was positive, negative, all those things. Well, let's do better than just say, okay, we think there is a line there. Let's go ahead and put a line right through the middle of these data points. What it's called is a least square regression line. And we're going to put the best line that we can possibly fit through there. And the math is going to do that for us. So if we're making a line, all the way back in high school, a line was this: y equals mx plus b. Well, it's going to be no different today. I don't know why we do this, just to make this confusing. We move everything around, but it's a line. We're going to put a line through there. And so in high school, b was the y-intercept. Well, now it's a. It's the guy sitting off by himself, and we move him to the front. In high school, m was the slope. Here it's going to be b. It's the thing for sitting in front of the x in both cases, but it's still just a line. We're going to create that line that goes through there. All right, now this is where the math comes from to create the line. Just real quickly here, you can get the slope of this line by the relationship, a ratio between the standard deviations and the directions, and multiply by the correlation. There's other ways as well. The other thing that you need to make a line is you need a slope, which we could get from this, and you need a point on the line. Well, it turns out that when you do this game we're about to do, the mean in the x direction and the mean in the y direction are a point that's always going to be on this line. So the moral of the story is we could do this by hand using these ideas, and we would create this least square regression line. Now be careful. We're going to put this hat on here to tell us that this isn't a real line. We don't know that this is all true. So you need this little hat on the y, and I'll talk more about that in a minute. Now, what you're going to do is you're going to clear out your list 1 and your list 2. You're going to put this in L1 and this in L2. Okay? Now, while you're doing that, you can pause the video. But real quickly here, so first you would want to establish who's the explainer and who's the responder. The explainer, the one telling the story, has to be the X, and the one responding to the story has to be the Y. Okay, so put those all in. When you got them in, we'll continue. All right, after you have all of that data in, you're going to go back to where one variable stats was. We did this before. There was a command called linreg a plus bx. Now, that's where you'd found the correlation. So run that again. Now, there was another choice. There was b plus ax, I think, is the other one. It would work if you did follow the same procedure. There's nothing wrong with it. But the textbooks for linear regression put the a and the b in this order. That's why we're choosing the choice that we've got. Now, when you get this output, you're going to have r there. You're going to have r squared, which is called the coefficient of determination. But you also now have a and b. So all you have to do is put those together to form the line. So here's the idea down here. I hope this matches with yours, this is our slope, so that would be the b, and here is the y-intercept, that would be the a. Now, I have one important thing, and a lot of people are going to continue to miss this, even though I'm going to warn you here. We don't want to leave it with X and Y. Okay, we want to put it in terms of the words. It needs a context. So what I'm going to say here is final exam. You can write it all if you wanted. I'm putting a hat over it, and I'll tell you more about that in a minute. Okay, I'm running out of room, but so this is replacing X and this is replacing Y. It's because it tells me there's a story here. Okay, I want to see that there's a story. The third exam, final exam. Okay, now we're ready to go. This is the best line that fits through these dots that we've been given. Now, hold on. I want to go in a different order here. The whole point of this is that we can predict things. We have established some kind of relationship here, or at least we think we've got one, and we're going to use this line to say, hey, let's just use this information. Let's just establish this line that runs through the middle of these guys. We say there's a linear relationship. Well, let's use it. And the value of this is here. I could go and find a good estimate for values that I didn't even have when I originally obtained my data. What do I mean? I could go to 73 and I could come up here and say, you know what? I think someone who got a 73 on the third exam should get 170, whatever that would be, on the final. Or I could come over here and pick one, or here. And so it gives me the opportunity, the power to try my hand at predicting. And in the business world, if you're making accurate predictions, you're making money. So we've created this in order to make predictions regarding data that we haven't had. We've tried to use the dots to establish this relationship. And if we've got a strong relationship, we can start making predictions. Okay, now I'm going to talk about the predictions here in just a second, but there's a couple things we need to see. You know what? I'm going to go to the predictions first. Let me change the order of this. So let's do that. Let's make a prediction. I want to see what would happen if a student got a 73 on the exam. I didn't have anyone who took a 73 perhaps, so I put 73 in for X. I crunched the numbers, and I'm expecting that, are predicting that they would get a 179.08 on the final exam. Now, I put this hat on here. The hat really means prediction. This is a prediction line. It doesn't mean it's the truth. It doesn't mean this is exactly the X you would get. It's the prediction. Okay, so they're doing some more of those. Now, here's a super important idea that is on the test. It's called the residual. We want to sometimes check to see how our prediction is doing compared to what happened in the real world. So you'll often see this. Here's your formula. The residual is the actual value, or sometimes it'll say observed, minus the predicted. So what do I mean by that? What did we get? What are we doing here? We were doing a 66. Look at what we got in the real world. The Y for a 66 was 126, a final exam score of 126. We're doing it down here. When we predicted 66, we got a 145.27. We're going to take the real world score that went with the 66, the 126, and we're comparing it to what we calculated based on our line. And what we have here is called the residual. It's telling us how far our line was off versus our prediction from the real world, okay? There are two things we need to interpret about this line. You'll often be asked to interpret. One of them is the y-intercept. So if we come back here, remember this was the y-intercept. So you're interpreting this in the context of the story, and it's not very difficult. What it means is this is the score that you would expect to get if there was an x of 0. That's what a y-intercept is. When x is 0, what do you expect for y? Well, x equals 0 means that you got a 0 on the third exam. So according to our line, if you got a 0 on the third exam, you would expect the y-intercept, which is a negative 173.51. Now, this often happens. So obviously you can't get a negative 173.51. That's impossible. So sometimes our little game breaks down at the y-intercept. It's very true. Often happens, but that's the interpretation. So when the third exam score is 0, we would expect to get a negative 173.5 on the final exam. Doesn't make sense, but that's okay. So why this happens is we start to have trouble. It's called extrapolation. If you try to make predictions that are outside of this area for our data, bad things begin to occur. It doesn't work because this line was established based on this range of data right here and not data values all the way close to the y-intercept or even values up here outside of this. So linear regression can be really helpful, but be careful of extrapolation, which is working outside the ranges. The y-intercept will often be a victim of that. Okay, one last thing is interpreting the slope. Now, people struggle with this, but it's not as bad as you think. If you remember from high school, a slope is the change in y over the change in x. So if you look back at our equation, I'm not going to flip back, but you see the slope was 4.83. This is all it means. This is like if you had a slope, it was like 3x plus 2. What we would do is we would put that 3 over top of a 1, so you know that you go up 3 over 1, up 3 over 1. Well, we're going to do the same thing here. 4.83 over 1. So what does this mean? It means when x changes by 1, the y is predicted to change by 4.83. But let's put it in terms of the story. So as your score on the third exam increases by 1 point, we would expect your score on the final exam to go up by 4.83. And that's it. Now I'll help you with that if you need a hand, but that should get you through.